Hi everyone, I am Aquib Ahmed. I am here to explain my instrumentation and measurement system project. Basically, our project was remote control obstacle detector report, but due to COVID-19, our project is now totally simulation based. I am going to explain the interfacing and simulation of my sensors on Proteus. My sensors include infrared sensor, ultrasonic sensor, current sensor, voltage sensor, and for data logging, I have used SdCard and RTC. For your kind remarks, I have attached a Google form in the description of this video. I must request you to please fill that form after watching my video as it is required by our course instructor. Okay, now first I am going to explain the interfacing and simulation of my infrared sensor. An infrared sensor basically emits and detects infrared radiations to sense its surrounding. The basic concept of an infrared sensor is to transmit an infrared signal. This infrared signal bounces from the surface of an object and the signal is received at the infrared receiver. Okay, now here we have the datasheet of IR sensor. The VCC is applied here. It is 3.3 to 5 watt DC supply input. The ground is in between. And the output of this sensor is low when the obstacle is in range. The power LED and obstacle LED are here. Power LED will glow when the power is given and obstacle LED will glow when the obstacle is in range. The distance is adjusted from here. When we rotate it counterclockwise, the distance will decrease. When we rotate it clockwise, the distance will increase. The IR receiver and IR emitter LED are shown. Now I am going to explain the Proteus part of my infrared sensor. Let me first define the pins. The V-out pin of infrared sensor is connected to the pin number 4 of Arduino and the ground is grounded. The VCC is applied 5 watt. The test pin is used to test the infrared sensor. Now I am going to the coding portion of Arduino and I am going to upload the code on Arduino. We have to find the hex file here. We can simply copy that file or we can also place that file from Proteus. Now there is the hex file. We are going to copy this. Now we are going to put that in Proteus. We will paste it here. And now I am going to run this. Now as you see, when the test pin is 0, the LED is off. When the test pin is 1, the LED glows. This is used to test the infrared sensor. Now my second sensor is ultrasonic sensor Hc-Sr04. Hc-Sr04 is an ultrasonic ranging module. It provides 2 cm to 400 cm non-contact measurement function. Its ranging accuracy can reach to 3 mm and its effectual angle is 15 degree. It can be powered from a 5 watt power supply. Now as for about the working ultrasonic sensor. Ultrasonic sensor work by emitting sound waves. It emits sound waves at a frequency too high for humans to hear. Then they wait for the sound to be reflected back, calculating distance based on the time required. It is the datasheet of ultrasonic ranging module Hc-Sr04. Its electric parameter includes its working voltage is DC 5 volt. It works at a current of 15 mA. Working frequency is 40 Hz. Its maximum range is 4 meter or 400 cm. Its minimum range is 2 cm. Its measuring angle is 15 degree. It requires a 10 micro. It is the Proteus part of ultrasonic sensor. 5 volt is applied here. The trigger pin is connected to the pin number 3 of Arduino Uno and the echo pin is connected to the pin number 2 of Arduino Uno. The ground is grounded here. Now like infrared sensor, there was a test pin. In ultrasonic sensor there is SIM pin. It is used to test the ultrasonic sensor. For example, when an obstacle is in front of ultrasonic sensor, we have to change its range in front of the ultrasonic sensor. So we have used potentiometer 1K here and I have applied 20 volts here. Now I am going to run this. First I am going to I have uploaded the code. Now I am going to run this and let me open the virtual terminal. You can see that distance is 11, in the range of 11. Now I am going to increase the potentiometer range. Now you will see the distance is changed to 12494, 12494. It is giving value of 12494 again and again. This is the My third sensor is ACS-712 current sensor. There are many types of ACS-712 current sensors, but the one I am using is fully named as ACS-712EL-CTR05BT. This Hall effect sensor detects the incoming current through its magnetic field generation. Once the current is detected, this Hall effect sensor generates a voltage that is proportional to its magnetic field. This magnetic field is used to measure the amount of current. It is the datasheet of ACS-712 current sensor. Its features include low noise analog signal path, device bandwidth is set via the new filter pin, 5 microsecond output rise time in response to step input current. It has 50 kilohertz bandwidth. And now in case of pins, there is VCC, VI out, filter and ground. There is a 1 nanofarad capacitor in between filter and ground pin, and VCC is 5 volt. Here I have placed a motor in my Proteus in the positive pin. And in case of its common operating characteristics includes its VCC is minimum 4.5 and maximum 5.5. Its supply current is 6 milliampere and maximum 11 milliampere. Here is my Proteus simulation of ACS-712 current sensor. As you can see, there are 4 pins VCC, VI out, filter, ground. There is a 1 nanofarad capacitor between filter and ground to filter the values of current sensor. VCC is 5 volts and VI out is denoted as current sensor. I have attached a motor here. The current sensor pin VI out is interfaced with A0 analog pin of Arduino. Now I am going to simulate my project. Now I am going to open the virtual terminal. Let us wait. Now as you can see, it gives the values of current 1 ampere. It is my simulation of voltage sensor on Proteus. The analog pin A0 of Arduino is connected to the potentiometer and I have applied 20 volts here. The TX pin of Arduino is connected to the RXT pin of virtual terminal and the RX pin of Arduino is connected to the TXT pin of virtual terminal. Now I am going to upload my now I am going to run the simulation. Let me open the virtual terminal here. Now as you can see, it is giving the voltage of 5 volts. Data loggers. Data loggers usually use a microprocessor, an internal memory for data storage, and a sensor to collect data. They are generally small and battery powered devices. Data loggers can either interface with a computer and use software to view and analyze the collected data. They can be a standalone device too. They are connected wirelessly too. I am going to explain my SD card part here in Proteus. There are 4 pins on SD card: CS, DI, DO, CLK. The CS pin is termed as connected data line 3 in SD mode and chip select as in SPI mode. The DI is termed as command or respond line in SD mode and data input in SPI mode. The DO is termed as connected data line 0 in SD mode and data out in SPI mode. The CLK is termed as clock in SD mode and serial clock in SPI mode. Now I am going to show you the interfacing of these pins with Arduino. You can see the CS pin is connected with pin number 10 of Arduino. The DI pin is connected with pin number 11 of Arduino. The DO pin is connected with pin number 12 of Arduino. The CLK pin is connected with pin number 13 of Arduino. These pins are termed as SCLK serial clock, MISO master in slave out, MOSI master out slave in, and SS slave select. Now let me remove my SD card first. And I am going to start my simulation. Now I am going to open my virtual terminal. Let us wait. As you can see, it shows not initialized. Now let me again insert my SD card and again start simulation. I am again opening my virtual terminal. Now it shows initialized and it shows the value of current and obstacle ultrasonic sensor. Now let me show you MMC file. Let me reload it. It is the SD card MMC file. You can see it shows I am inside folder, distance is, current is, I am inside folder, LED is glowing. It is also showing LED is glowing. This is our portion of SD card. RTC, real-time clock. An RTC maintains its clock by counting the cycles of an oscillator. It has an external 32.768 kHz crystal oscillator circuit or an embedded quartz crystal. It can detect transitions and count the periodicity of an input that may be connected. It is the datasheet of real-time clock. It counts second, minute, hours, date of the month, day of the week, and year with leap year compensation valid up to 2100. 56-byte non-volatile RAM for data storage, 2-way serial interface. In its pins connection, there is VCC, SOUT, SCL, SDA. It is the Proteus simulation of RTC. There are 4 pins: SCL, SDA, SOUT, VB80. The SCL pin is interfaced with the analog A5 pin of Arduino. The SDA pin is interfaced with analog A4 pin of Arduino. Now you can see there is a crystal between pin 1 and 2. The crystal is an oscillator. Now I am going to run my code. Now I am going to explain my code. We have included 3 libraries: spi.h and sd.h are for SD card, and rtclib.h is for RTC. We will make an object myfile that stores our data. We will declare pin for SD card chip select is 10, echo pin for ultrasonic sensor echo pin is 2, trigger pin for ultrasonic sensor ping pin is 3. The initial distance is 0, so the ultrasonic gives no garbage value. Now I am going to my ultrasonic sensor portion. First of all, I am declaring the pins: pin mode, ping pin output. The pin 3 is as output trigger pin and pin 2 as input, that is echo pin. Now this is our ultrasonic sensor portion. Ultrasonic sensor works by triggering it, and it is triggered by a square wave. It needs 10 microsecond pulse to trigger it. First we will give it low logic to trigger for 2 microsecond, then we will apply high logic to trigger for 10 microsecond, and again we will apply low logic. This will form a square wave. Now the echo pin is at high. Distance is duration multiplied 340 divided by 2. It will save the time of flight by using the same concept as velocity is equal to distance divided by time. The factor 340 divided by 2, it is the speed of ultrasonic wave here, and it will return the value of distance. Now I am defining my current sensor. Current sensor is defined at analog A0. The initial value of current is 0, so that the current sensor gives no garbage value. Offsetted value is given as, and the converted voltage is also 0. We are declaring a set of array for 10 readings, and the total is also 0. The reading number is 0. The average is 0 at initial level. Now I am going to my current sensor portion. To stabilize the current values, we will take set of 10 readings, we will form an array and calculate average of those readings and divide them by 10. We will analog read current sensor and add the values. Then we will give an increment, this will add the number of readings. We will form an logic. If number of readings become greater than 10, we will again set the reading value to 0. We will take the average of all of those values by dividing it by 10, and the converted voltage is average multiplied by 5 divided by 1024. The average value is an analog value. We will convert it into equivalent voltage by multiplying it with 5 and dividing by 1024. Current is converted voltage divided by 0.500. We will divide it because the sensitivity of our sensor is 500 milliwatt per ampere. The value of current is subtracted from offsetted value and it will return the current. Now as I have declared chip select is equal to 10, the pin for SD card. First of all, let me explain IR sensor. We have defined LED at pin 9 and the IR sensor is at 4. In white setup, we have used serial dot begin 9600. 9600 is the baud value of serial monitor. SD dot begin initializes the SD card. The pin mode 13 is output. Pin mode IR sensor is at input. Pin mode LED is output. Here I have used a logic. If SD card begins, for example, if a SD card is initialized and it is putted in the terminal, then it will print initialized, otherwise not initialized. Now for IR sensor, if it is high, it will check the output and set the LED on. In SD card, we will create a file named folder and this will write the data here. I am inside folder, LED is glowing. Otherwise, there will be I am inside folder, LED is off. It will print whether the LED is on or LED is off in the MMC file. Same for ultrasonic sensor, it will create a file name folder and tell SD card to write data on it and will open that file. This will save all the data below. This data will be saved in the file and will close the file. Now for voltage sensor, in void setup we have serial dot begin 9600 initialize serial communication at 9600 bits per second. In void loop we will do sensor values analog read A0. Read the input on analog pin 0. And this will convert, now we will convert the analog reading which goes from 0 to 1023 to a voltage 0 to 5 volt. For this, we have voltage is equal to sensor value multiplied by 5.0 divided by 1023.0. This is the formula. And now we will print the voltage. Okay, my simulation is completed. Please fill the Google form. I have given the link below in the description and give your remarks. Thanks for watching.